Hello and welcome. In this math tutorial, our task is to solve the radical equation given on the board. Now let us look at this equation. In this term, you can see the cube root of x plus 1. And in this term, you can see the cube root of x plus 1 squared. Now, I hope you know that this term can also be written as the cube root of x plus 1 squared. That is the square of this term. Now, with this observation, we are going to start this solution with a very simple substitution. We are going to call this quantity d. So, let d be equal to the cube root of x plus 1. Now, you know that the next thing we are going to do is to cube both sides of this equation. When we do that, we have that d cubed is equal to the cube is going to take care of the cube root, leaving us with x plus 1. And of course, when we subtract 1 from both sides of this equation, we are going to have that d cubed minus 1 is equal to x. Now, the next thing we are going to do is to rewrite the original radical equation in terms of d. Here we have 3 times x. But now we have that x is equal to d cubed minus 1 plus the cube root of x plus 1, which is equal to d, plus the cube root of x plus 1 squared, which is equal to d squared, and everything is equal to minus 1. Now let us open this bracket. We have 3 times d cubed, which is 3d cubed, 3 times minus 1, which is minus 3, plus d squared. And let us bring minus 1 over from the right hand side to the left hand side. When we do that, it becomes plus 1 and we are left with 0 on the right hand side. Now let us rearrange this. We have 3d cubed plus d squared plus d. Now we have minus 3 plus 1, which is equal to minus 2. And this is equal to 0. Now you can see that we have reduced the original radical equation into a cubic equation. The next thing we are going to do is to solve the cubic equation for values of d. And then, of course, we'll go back to this equation to find the value of x that satisfies this radical equation. Now, to solve this equation, let us remember that if this cubic equation is going to have a rational root, then that root is going to be a factor of plus or minus 2 divided by 3. So now what we are going to do is that we are going to test 2 over 3 to see if it is a root of this equation. How do we do that? We simply substitute 2 over 3 for d into the left hand side of this equation and see if we get 0. If we get 0, then 2 over 3 is a root of this cubic equation. We have 3 multiplied by d is now 2 over 3 cube plus 2 over 3 squared plus 2 over 3 minus 2 over 1. 2 cubed is 8. And 3 cubed is 27. Of course, we still have 3. 2 squared is 4. And 3 squared is 9. We have 2 over 3 minus 2 over 1. 3 into itself is 1 and into 27 is 9. This fraction is now 8 over 9 plus 4 over 9. Let us write 2 over 3 with 9 as the denominator. To do that, we simply multiply both the numerator and the denominator by 3. So 2 times 3 is 6 and 3 times 3 is 9. We do the same thing here. 2 times 9 is 18, and 1 times 9 is 9. Now that all four fractions have 9 as their denominator, we can simply deal with the numerators. Here we have 6 and here we have 4. 6 plus 4 is 10 plus 8, that is 18. So this is 18 over 9 minus 18 over 9, which of course is equal to 0. So that means that 2 over 3 is a root of this cubic equation. That is, we have that d is equal to 2 over 3. Therefore, d minus 2 over 3 is equal to 0. And when we multiply through this equation by 3, we have that 3d minus 2 is equal to 0. So that means that 3d minus 2 is a factor of this cubic equation. So to get the other factor of this cubic equation and hence factorize this cubic equation, all we have to do is to divide this cubic equation by this factor. And to do that, we are going to use the synthetic division method. So we draw our L. The coefficient of d cubed is 3. The coefficient of d squared is 1. The coefficient of d is 1. And the constant term is minus 2. Of course, we are dividing by 2 over 3. Now we bring down 3. 2 over 3 times 3 is going to give us 2. 1 plus 2 is 3. 2 over 3 times 3 is going to give us 2. 1 plus 2 is 3. 2 over 3 times 3 is going to give us 2. Minus 2 plus 2 is 0. Of course, you know that this is the coefficient of d cubed. This is the coefficient of d squared. This is the coefficient of d. So since we divided by d to the power 1, this is going to be 1 less than this. So this is going to be the coefficient of d squared. So this is 3d squared plus 3d plus 3. Now, the last thing we are going to do is to divide this polynomial by this denominator, which is 3. When we do that, we have d squared plus d plus 1 as the quadratic factor of this cubic equation. So what this simply means is that the factors of this cubic equation are 3d minus 2 and d squared plus d plus 1. And of course, this is equal to 0. Now, at this point, of course, you know that this statement simply means that either 3d minus 2 is equal to 0 or d squared plus d plus 1 is equal to 0. Now, before we solve this quadratic equation, let us first of all check to make sure that it has real roots. And of course, you know that for us to do this, we have to employ the discriminant of this quadratic equation. The discriminant is b squared minus 4ac. For this quadratic equation, b is 1, so we have 1 squared. A is 1 and c is 1. So we have 1 minus 4, which is minus 3. Of course, you know that for a quadratic equation to have real roots, then the discriminant must be greater than 0. Now, in this case, the discriminant is less than 0. So it simply means that this quadratic equation only has complex roots. So, in looking for the values of x that satisfy this radical equation, this equation is useless to us. So we go back to this. From here, we have that 3d is equal to 2. And of course, we have that d is equal to 2 over 3. So that simply tells us that 2 over 3 is the only real root of this cubic equation. Lastly, we go back to this equation to find the value of x that satisfies the radical equation now that we have found the value of d. So substituting into this equation, we have that x is equal to 2 over 3 cubed minus 1. 2 cubed is 8 and 3 cubed is 27 minus 1. 27 times minus 1 is minus 27. Minus 27 plus 8 is minus 19. So x is equal to minus 19 over 27. So this is the value of x that satisfies this radical equation. And with that, we come to the end of today's exercise. I hope you learned something new. If you enjoy such content, please subscribe to the channel. Leave us a like to support the channel. Thanks for watching and see you in the next video.